All right, welcome back. And one of the things I wanted to throw out is sometimes just some interesting news. And I thought this was interesting in the standpoint that we can do it. Horrible because the company apparently went under and now these people have an implant that literally turned off. So there are now some retinal implants apparently for several years. So they look something like this. They don't give great vision. They give like a 20 by 40 square of like light and gray and dark. But for somebody who's completely blind, it's a way that they can get some visual information. Well, if you read the story, several of them have had, it just powers off and doesn't come back. And the company that was making this basically is just dissolved now, which I think is kind of a sad thing. So there's an interesting tale there. And so my first thought was, well, other people are doing that, but apparently once you've got these implants, it's hard to switch to another model or another company. Those surgeries don't always go very well, but I just thought that was important to see how our programming can lead to changes in people's lives and also some interesting pieces in there in terms of what happens when we don't support it. So a couple of things really quickly. So this week we end on the 27th. So just to be aware of that date and when we are ending this entire item. So there's a lot of assignments in here. We've looked at truth tables, and we're going to start working this week on a couple of these coding assignments, trying to make sure that we have the same ideas in our brain. We've added some extra material, and in fact, I've got something kind of interesting we're going to do today. Now that we're starting to see that there are loops, we're going to actually take a look and see if we can build a clock. Now, is our clock going to be 100% accurate in time? No. But what I want to look at is how we can nest those loops into a concept that we've seen before, that you're used to, and how we can use the idea of these nested loops. All right, so if I remember, did we do 3-2? We had a business contest, and I was gone a day, so let's take a look at... I have my notes say I started 3-2, but I'm not sure that we finished or looked at it. Oh, yes, the right triangles. Okay. So the first problem looked at, is a triangle going to be, in that case, an equilateral triangle? In this case, we need to figure out if a triangle is a right triangle or not. So enter the first, second, and third side. Now, what I'm going to advise you is, if you've already done some of those pieces, though this is the one class that you can copy and paste from yourself, and in fact, some points we'll show you some websites where you can get other coding, and it's not a problem. If you attribute it to the right place and it's your code, that's fine. So I'm actually going to jump back a step, and I'm going to go back to 3.1 because I can actually move my code from one place to another. Come on, Cengage. Bless you. Bless you again. You think it would be cold enough to kill off all these? Alright, so I'm just going to grab this and all of it, and I'm going to copy it. So, copy. And then I'm going to launch 3-2. So I have kind of a start. And there's other ways we could do it, and I'll show you some of those as we go through here. But start assignment. Come on. All right. So my name didn't change, but what I might want to change is this test for right triangles. So some of this that we're doing, the side A, side B, side C, we're doing the same piece. So this we can reuse. We can reuse this code pieces right here. doesn't present any issue. Where we're going to find that it's a little more complicated is these statements here. So I need to figure out, how do I determine if something is a right triangle or not a right triangle? So we need to come up with a mathematical model to figure out how to do that. So the model we typically use is a squared, let's see, a subscript. So a squared a squared plus b squared equals c squared. So if we think about a triangle that's got sides of 3, 4, 5, I can easily see that 3 squared is 9 plus 16 is equal to 5 squared, which is 25. And that tells me that it's a right triangle. And you think, well, where am I ever going to use this? If you're building a house, for example, that's the same math that you use to square up your foundation, because you can quickly determine by measuring from corner to corner if something is a square using this very formula. But for us, we need to figure out how to calculate this. So there's a couple of different ways that come to mind. So method A might be, we don't know which side is the longest. So we could come up with a way to reorganize A, B, and C. So all those sides, and we could put them in order. And then the largest would be equal to the next two smallest squared and added together. And we could test to see then if that worked. That's one way we could do it. What might be an easier way programmatically, so down here, make this a little bigger, we said when we were looking for the triangle to be equilateral that all three sides had to be equal. So we used an AND statement. What if I did this, though? And so I'm going to leave my parentheses in here. So what if instead I'm going to put all three models in here? So if side A to the second power is equal to side B to the second power plus side C to the second power. So if that piece is true right there, if that piece is true, then this triangle is a right triangle. In fact, I'm going to copy this verbiage right here, so I don't have to rewrite it. Triangle is a right triangle. And I'm going to say it's not a right triangle. So I'm just going to copy that in and out like that. So now I have all three pieces here. So side A squared equals side B squared plus side C squared. So if that happens to be true, so side A would be the long one, and we can run it and see what happens. So in this case, line 2. Oh, I have to put a... So if we run this, now I'm going to put the data in backwards because I want to try it with my longest side first. So the first side is 5, 4, 3. Now, in this case, I can't compare them because I'm before we just compared them string to string. In this case, I do need to go in and change those to some kind of number. So I think everybody's going to put them in as integers, so I'm just going to convert it to an integer. Make sure that my parentheses match. And so we'll put another one at the end. Now we can run it again and see if that's converted properly. So 5, 4, 3. And it says, oh, the triangle is not a right triangle. Huh. Now, when I put that in there, I would have thought that this would give me a result that says that is true. So, triangle is not a right triangle. So let's take a look, and here's where sometimes adding those print statements and different things can be advantageous. So I think that side A squared should be equal to this value. So I'm going to add one more line in here. So I'm going to try to come up with this same value myself. So I'm going to put a print. And I want to know what this is right here. And I can use my copy and I can print that out. And then I also want to know what this value is. So I want to see if it's calculating the same way I think it is, or if we have something weird. So I can put in these values here because I'm going to calculate the square root of side A and the square root of side B plus the square root of side C. So I'm going to run this again. 5. Oops. Well, I can do it this way. Huh. That's interesting because now it says that it is a right triangle. But maybe I have something wrong because take a look at what the values it gave me for these. So it said side A to the second power is 6. Does that seem right? So side A squared, which we put in the value of 4, it says it's 6. And then it says side B squared plus side C squared equals 6. So maybe we have a problem with the way we're calculating something in here. So instead of using this squared function, let's try to see what happens if I put times side A. So it should give me the same result if I put those in. 4, 3, 5. Oh, it doesn't give me the same values. So do I need to look at how to do exponents then in Python? Maybe we better take a look real quick. And so I'll do a search. No, so it's not the power symbol like what we would do by hand. So 5 to the third power, 5 times 5 times 5, but we actually use the double asterisk instead. All right, so let's go back in and try to change our code a little bit then. So I'm going to change this back to then I will change these two then to all right. Now we haven't changed our formula here, so this is going to give us an incorrect value. I just want to make sure that, so in this case, it should really say, yes, you have a right triangle. We said, okay, we figured out how to fix our exponents. So apparently Python doesn't work the way our brain would do that, but so here we can change that out and say, so if side A to the squared or second power now we can run it one more time. 5, 4, 3. And it says, hey, it's a right triangle. All right. But what we don't have, so if I put them in a different order, a 3, 4, 5, it's going to say it's not a right triangle. And that's because we have side 1 squared is 91, or 9, compared to 41. So I'm going to take these out. They've kind of served their purpose. So here's where the difference between and or is important. So if I said and, all of those conditions had to be true to make an equilateral triangle. If I use an or, I can actually make it where any one of these conditions is true. So I could take this statement and modify it for all three possibilities of where those values are going to be. Because I know that my hypotenuse is either A, B, or C. So if I then said, what happens if I put side B as the hypotenuse, and I square it, and then I add A and C, or I have the other option where it's side C. So I could manipulate those around with a set of values. So when I go to grade it, it's going to give me, in this case, it'll probably give me about a 1/3 because it's going to try one possible combination and then hiccup because we're not checking for other possibilities. So in this case, it says, nope, you didn't pass because all of the cases it gives me, it doesn't finish out like we would like it to. So I need to be able to check other models. Now, so one model might have been in here if we had some way to make A the biggest. So you could shuffle data around to do it, or in this case, you could use a set of or statements and do something very similar here. So you could come up with that or statement, flipping around which side is the hypotenuse, and you could measure it three different ways that way. Both ways work. There's advantages to both of them. This is kind of quick and dirty, and leaves the data in the original variables, which is kind of nice. So this program does work really nicely when it's because it doesn't like me. So I put an or statement, but I didn't put anything behind it, so it's going to argue with me there. All right, so as long as my data comes in and it's biggest side first, so if it were 45, 20, and 5, it's going to say, nope, it's not a right triangle. Okay, I would hope not. So this is one model. You can certainly rearrange the data to get to a couple of the other ones or ways to do it there. Let's take a look at this one really quickly. We'll learn or load. Come on. There we go. Yeah, that's not good. Come back. Okay, one more time then. Are you guys able to open 3.3 up, or is this a Cengage issue? Or my issue? You can't either? Oh, thank you, Cengage. Huh. Well, how about this? I don't know who's able to get into it. Sure. How about that? We'll just take that one right out of there. Let's see if 3.4 will launch. Somewhere. All right. So this one is a little more interesting. So this combines a couple of interesting features in here. So this one says we're going to get a couple of things out of there. So let me move this over so we can see the whole output. So enter the height from which a ball is dropped. Enter the bounciness index of the ball. And enter the number of times the ball is allowed to continue bouncing. Got it. All right. So we need to get some additional information. So the height tells us where we're going to start at. So 25 feet. And the bounciness index says that is the value that we multiply the original by. So if we start out with 25 feet as our initial drop, the ball's going to hit the ground, and if we're at 0.5, it's going to come back up half of that, or 12.5 feet. And then it's going to fall again. So imagine you get your new bouncy ball, 9 years old, and it's a great Christmas. So the next one then is going to be 6.25. I should have done a number that was a little easier to use there, but. And then if we continue to allow it to bounce, then it's going to be 3 point, whatever that is. And then it's going to be 1.5. So every time it goes down by the index. So this one's going to do a loop. So we're going to have to create a loop of some sort. That loop has also got to have a way to end. So we're going to input a lot of items, and we're going to say this is how many times that loop is going to run, and then it's going to output how many feet or inches or whatever units we're using. So in this case, they use a generic, hey, this is just a unit, and we can then see what's in there. So let's take a look at this a couple of ways. So I know that I'm going to have to put my name in there and all these normal things so that when I see your code, I don't yell. So problem 3-4. Because 3-3 apparently isn't going to come up for us. So I need a couple of variables and to think about what's going to happen. So I'm going to get a variable of height from when somebody enters a value, right? So I'm going to call that one initial height. And I'm going to set that equal to 0.0. Now, that tells Python that it's going to be a float number. I'm going to say the bouncy, and I'm going to set that equal to 0.0 also. And so initial height, and then what we could call this anything, number bounces equals 0. Now I'm going to probably use that as an integer, just simply because it makes some sense. So we'll need a total distance, and that's going to be a float. So we have to calculate that. So this gives me a lot of my pieces. So I'm going to construct some of my input statements here. So I'm going to say initial height is equal to the input of, and notice that I'm just going to copy and paste that because that makes my life easier. Enter the height, okay. The bounciness index, so we are going to call that bouncy, equals input, and I'm going to put this bounciness index. And then we called this one number bounces, input. And I'm going to copy and paste this in right here. Enter the number of times the ball is allowed to continue bouncing. So now my user, so if I ran this right now, just to double check and make sure we haven't done anything weird. So I know I see I need to put a space there. Probably a space there, probably a space there. Alright, so enter the height the ball is dropped from, 20, the bounciness index 0.5, and we're going to allow it to run 10 times. So our program doesn't actually do anything because we get 0 information back out of there right now because we haven't constructed. So I'm going to go to then main code or whatever I'm going to call this. So I know that this is where I'm going to make some of these things happen. So enter the height from which the ball is dropped. So I might want to bring over my notepad and think a little bit about what I'm doing here with this. So each time that ball drops, it comes down. So I need to keep a running total of how many bounces it has. So I need to have some kind of a loop. And so we looked at a for loop, or we could do a while loop. So while some condition is true. So I'm going to add one more variable up here, loop counter, just so it makes it really plain what it's doing. So while loop counter is less than, and we said the number bounces. So while that is true, so while that number is less than my loop counter, then I'm going to do a couple of things. So I'm going to say total distance is equal to total distance plus, and maybe we're going to have then a number also. So let's go, we'll call it bounce height. Okay, so total distance equals total distance plus bounce height. Well, I don't know what bounce height is yet. Let me move these around a little bit so you can see a little easier. I don't know what bounce height is yet. But I know each time we calculate it that gives me a different value. So total distance equals total distance plus bounce height. So now maybe I have to figure out what bounce height is. Bounce height is equal to the last bounce height. So maybe I need to think about this a little bit. So bounce height equals bounce height times whatever we called our bouncy, the bounce index. Okay. Now, I may have to look at my order of this, because this first time through here, I'm not going to have one in there. So maybe I move that on top. So I calculate this first, and then I add it back down here. So outside of my loop, I may need to do something also. So right now, total distance is 0, and I'm adding the bounce height. But I need that initial value in there also. So total distance, to start with, is going to be equal to initial height. So in other words, we plug in the first value. And so while this loop counter is less than number of bounces, that's going to happen. And then outside of that loop, let me move this over so I can get the total distance traveled is, so I'm going to have an output or a print statement once we get out of the loop. Copy. Total distance traveled is, comma, total distance, comma, units. So now I take a value in, total distance, so I kind of want to do what we call a desk piece here. So I see my notepad over here, so sometimes I scribble this out. So when we first run through here, if you put in a value, so let's say that you put in an initial value of 10, and you said my bounciness is 0.1, that's easy to calculate, and you're going to let it bounce twice. So it's going to hit and come back up. So when it first comes down, my total distance is going to equal 10. So that's my line here. Total distance equals initial height. Then I have to add in the bounce, so when it goes back up. Well, 0.1 of 10 is plus 1. So that's one bounce, right? So the next time then, as it comes through here, bounce height is now only 1. So bounce height times bounce height, so it's going to say 0.1. And then we're going to add those all up. So 10 plus 1 plus 1. So I think I should get 11.1. All right, so let's test that hypothesis, and let's run this and see what happens. Do I have to find loop counter? Oh, there we go. Hang on. Equals 0. So, enter the height from which the ball is dropped. So I'm going to say 10. The bounciness, I'm going to say 0.1. And we said 2, right? Oh. Okay. Well, let's see what we got going on. So we have a type error of some error. So let's see what we have here that we need to do. So type error between int and string. So we're trying to compare two things that are not the same. Enter the bounciness index. Okay, so we know we need to take that a float because we're probably going to have a fraction in there. Initial height, we know that's probably also should be a float. bigger still. Chunk. Okay. And the number of bounces, that one could be an integer. All the way to the other side of it. Make it even bigger. Maybe not. Alright, so enter the number of times the ball is allowed to continue bouncing. Alright, so now we've converted those. So now let's move this back over so we can run our program and see what happens. Enter the height, 0.1, 2. Oh, what's happening? I don't see anything happen. Okay, so I'm going to do a control break. I'm going to come in here. I'm going to say, well, I don't see what's going on here. Let me see if I can look at this code and take a look at it again. So, yeah, we're adding that piece in, and we're looping here. So maybe I should print, just add an extra print statement in here, because I like to do those, so I can see what's happening. And I want to print, let's print total distance and see what's happening to our number here. All right. So this time, when we run it, we're going to do the same thing, 10.12. Oh, wait a minute. Holy cow. What's going on here? 10, 10, 10, 10, 10, 10. So we've created a loop that doesn't seem to break. So if I do Control C, that'll break it. And now it should be stopped. All right. So what I didn't do, so this loop counter, I need to do a couple of things. We set it equal to 0, but do we ever change it? It's less than number of bounces, so I need to have a statement in here that says loop counter, so our sentinel value never changed, equals loop counter plus 1. So every time it loops, it should then add 1 to that. So maybe I also add, I want to look at loop counter in there also in my print statement. So, and that's the only way to learn how to do these, guys, is you have to try and fail. You learn a lot more out of failing than you do from succeeding on this. All right. That. Control C. Why is it not breaking for me? Well, I know one way to get out of it. Let's do this, and I'll come back into it. So, somehow your loop has to have some way to change. So in other words, I have this counter, so it's got to have an escape out. And so that's what this happens to do. So we have to change that sentinel value, we're going to call it. So 10.12. All right, hold on here. So we get a couple of numbers, and my loop counter does go to 2, but my total distance is staying at 10. So I've got something wrong in my coding here. Total distance equals total distance plus bounce height. Bounce height equals bounce height times bouncy. So that confuses me, so I'm going to add one more statement in there. So I'm going to print out also, then I'm going to print out bouncy, perhaps. Or bounce height. Let's do bounce height. So, I'm going to run my program again. 10.1, 2. So somehow my program isn't calculating this bounce height correctly. So my total distance would be adding up correctly, except it's somehow telling me that bounce height is equal to 0. So we say it's 0 up here. So a couple of things we want to check. Did we use the right name here? So when we get this value of bouncy, did we somehow change that? So I would look at that. Total distance equals total distance plus bounce height. So are those values the same? So this somehow is getting us a 0. So how does bounce height become a 0? So enter the bounciness index. So one way we can try it, let's do this. So let's try this to bounce. And up here, oh, look at this. So up here we called it number of bounces. Okay. And up here we had bouncy as a number. So let's go back and let's just put bounce. So now we've changed that variable. Maybe it's easier to spell. So total distance is equal to that initial height. That still should be fine. Bounce should equal the bounciness index of the ball and number of bounces. So bounce height should equal bounce height times bounce. Does that make sense? So if our conjecture is true, then whatever this value is, so bounce height each time it travels should be this. So our bounce height initially times how many this bounce has. So here's our problem though. And I'll give you a hint. What's bounce height when we come into this initial loop? Is there any value in bounce height originally? So we say it's bounce height times bounce, but bounce height isn't assigned a value yet. So let's do this. Bounce height is equal to, and then we want our initial height. So initially we're assigning it the same value. So total distance and the bounce height are initially the same value. So now if I run this, let's see if that makes any difference. See if I do anything else really dumb here. Alright, I'm going to start at 10.12. Oh, well that gives us a result that seems like it's correct. So maybe we should try it for another number just to see what happens. So a height from which the ball is dropped, let's go up to 200 feet. And the bounciness, we're going to do 0.7. It's a super ball, and we're going to allow it to bounce 100 times. Huh. That looks like it maybe is working. Let's try something else. Let's try this. So we're going to drop it from 100 feet. But I'm going to say that that bounciness, though, we put in 2. Somehow, we've made something that violates physics. Because each time it does, it doubles instead of... So, I think in this case, what we may need is another sentence in here. Because we don't really tell people what the bounciness index should be. So, maybe up above bounce, we put just a print statement. should be less than 1. Now, there's some other ways we can do this. So enter the height, so 100 feet, bounciness is 0.5, and 10. So there's a couple of other things we probably should do to this if we were running this as code. I would take this inputs and validate them. So we might say we want a range of numbers. So I don't want to put in the bounciness index is 0.999, and we want to do it because now it's going to sit there and take a long time to calculate that. It will eventually, maybe, inside of there. So a lot of times what we want to do is put some restrictions on what people do with their data. So we're going to get there pretty quickly about that. It's still grinding away. We'll let it go for a little bit. But if I check this then, let's see what the checks give me. And it may not because it's still running this thing. So I'm going to look here and see what it says. Test for height of 0, index of 0.2 and 10 bounces. Test for height of 100, index of 2 and 5 bounces. So, but I suspect that is because we're running here for the next 10 years. All right, so that's one way that we can do that. There's a lot of different ways to solve something like this. This is one way using a while loop. We could have used a for loop and done the exact same thing. We could have put in that for 1 to our number of bounces. So a lot of different ways to do this. We get the same output, hopefully, no matter how we look at those. All right. So I'm going to actually launch idle really quickly, and I'm going to launch a new file. So I'm in my not in my interactive mode, I'm in my batch mode essentially. And so I'm going to do a couple of things. I'm going to put in just some identifying marks, and I'm going to quickly save this so I know where I'm saving it as. And documents, Python files, and I'm going to call this one clock. So the very first thing I'm going to do is I'm going to do seconds. So we know that there are seconds in a minute. How many seconds are there in a minute? How many seconds in a minute? 60. Okay. So what I want to do is I want to print a value called second. And I want to do that inside of a loop so it increases until I get to 60. So I'm going to do it as a while loop. So while seconds less than 60, I want to print seconds. Now, I need to tab that out because remember those are the things that are going to happen inside of there. Print seconds, and then I'm going to say seconds equals seconds plus 1. So every time this loop runs, this inside piece out here, it's going to print the second out. And let's see if we can actually make this work. So the other piece I know I'm going to have to do up here is say seconds equals 0. So that way that variable is initialized. Oops, I can't apparently spell, so that's not good for today. So if I sit there and I run this, and that's why I saved it first, so I just be able to go and click OK. Now, so it counts up all the way from if I scroll back up from 0 to 59, so that's 60 elements, right? But we don't count 0 as a second, do we? Well, we do in a clock, if you think about it. So our clock goes 0, so at 12 o'clock, 000, we're at 0. And at 59, it triggers that to spin over to the next item, so a minute. So I'm going to say that that does kind of what we want it to do. So it counted all the way to 60. Now, it certainly was faster than a clock, but that's okay because we're going to use this for some other pieces first. So this is our seconds loop. Now I want to include that seconds loop in a minute loop. All right, so the minute loop here, we're also going to have a while statement, while minute, and it's going to look very similar because we also, at 60 minutes, flip to an hour. Yeah. So while minute, and so now I'm going to do something very similar. I'm going to say minute equals minute plus 1. Here's where I think we get the interesting part. So I'm going to move this entire while statement out here so that it runs inside of, so this is all pieces that are going to happen inside of this minute loop. And I'm going to change my seconds piece here, my print statement, a little bit. So now, I'm just going to move it down so it's easier to see. I'm going to print minute second. So, what I've done is I've looped, I'm trying to put one loop inside of another loop here. So, let's see what happens if I run this. So it says minute is not defined. Okay, so I need to come up here and say minute equals 0. I'm going to double check and make sure I call it minute, minute, second, seconds. Okay. And I'm going to try to run it again. And so notice what it does here. I print out 1 minute, and it prints out 1 minute and all of the, okay, so we need to probably come back and examine our loop a little bit and see what it's doing and why it's doing that. So it runs this inside loop, but this outside loop doesn't seem to get a lot of movement because we only got the 1 minute, right? So what if I move this around a little bit? What if I moved my so while seconds are less than 60, it's going to print the minute and the seconds. And then at this level, so hang on here. Then it's going to do that. So I'm going to get rid of this piece down here. Alright, so. Alright. Now notice I had to go back in here and do some spacing. So those tabs are important because that's how it tells that while this loop, this is all inside of it because it's based on that indent. So now I might want to try and run this and see what happens. Alright. So, well, a little better. We got a 0, but it didn't turn over while minute is less than 60. So what happened here? Why is that statement not running? So this while loop ran, right? And as it finished, it should have kicked out to here, except it didn't seem to do that. So we're going to reformat and show you how important this formatting is to running. So it still didn't work. Okay, so next step of what we need to look at here. So what if I move this minute inside of here? What do you think is going to happen? Oh, look at that. 0. But then it looped, but each time it did a second, it also did a minute, right? So that's got to be on that outside loop. So why is it stopping at 0? Why are we not getting minute equals minute plus 1 and coming back up here? So it looks like the same kind of structure. So while minute is less than 60, so we can test it out. If you want to do something, we could do this. We could just delete that. So while minute less than 60, and then print minute. Well, that works now. Why does it not work when we had it inside of there? So minute plus minute, print minute. So while seconds less than 60, and then we're going to print seconds. Go back to 2 version there. Print seconds, and then seconds equals seconds plus 1. All right. So let's see what happens on this run. All right. So we got it to run through the seconds once, and then it did it twice. But why only twice? And so that's kind of our question here. So it says we printed the minutes and we printed the seconds. So what it really did was it ran this first time, it printed all of the seconds, and then the first time it printed all the minutes. So is it this white space causing us issues? So this internally should run and display our seconds. Then it should go through and display our minutes. So this is really that idea of we have to try to get it to do what we'd like it to do. All right, and we're still not getting our minutes and our other ones to loop. So maybe we need to go look at our while loops and see if there's something really weird inside of our while loop. We can rearrange things a little bit. So print minute. And we can do a lot of testing. So anything you want to do, that's the way we figure it out, is we test it and we say, all right, in this case it should print So it gave us something weird. It gave us our 0. So maybe we need to take out this statement then. So we've got to figure out why we're not able to print that minute, why it's not going up. We tell it to here. We say minute equals minute plus 1. And we don't want to put it into this loop, because then every second we'd increase a minute. So we need to figure out what's going on there. And so we will work on that on Thursday. This will be part of your final. You will have to build me a clock application. So we're going through these where we're going to have nested loops. So eventually, we're going to have inside of here, we're going to have a second, we're going to have a minute, we're going to have an hour, and then finally a daily. And so it will be essentially a clock. So play with these loops and see if you can make this work. You don't have to have 40 lines, and just 2 nested loops to see if you can make them work. Python, this is one of the areas that gets just a little tricky. It has to do with spacing and the indents, which makes life kind of miserable, unfortunately. Not horrible, but it makes life a little more interesting. So I would think we could do it really quickly, but I keep trying it, and I get, well, the inside loop runs, but the outside loop doesn't. So we'll work on how to create those for your test at the end of the year. And it's just kind of fun to be able to create a clock. So the other piece I throw in here, at the very bottom, I threw in some code that might be handy to use. So I'm just going to paste it here so you see what it is. Obviously, we're going to put some of these things up front. So this actually goes out and gets another library. This one says I'm going to get the library called OS. That library OS will allow us to see what kind of operating system you're running on. We're going to create a function, which we haven't done a lot with yet, but we're going to have a function called screen clear. Well, that screen clear is going to work a little different whether you're on a Unix style, so Android, Mac, Linux, or a Windows platform. And what we're really doing is printing out a whole lot of text, but blank text, so you can wipe the screen. So if I were to run this, I'll just delete this really quickly, and I'm going to run this. So it's going to say, hey, you have an NT-based system. Then if I look back in my code, it's going to tell me what that OS name is. So it's going to bring that out for me. So if it says OS is POSX or POSIX, we know that it's probably a Linux style system. So if you're on an Android, this is what you're going to get. So it's going to print out the name, and then it's going to print out an output, and then we're also going to increase one called sleep 5. So sleep 5 waits 5 seconds. Kind of a handy function. So if we wanted to wait longer, we could do that. And then it calls this function called screen clear. So up here, here's where we run that function. So it comes up here and it says, all right, if OS name equals POSIX, so only if it's POSIX will it do it, and then otherwise, it says, nope, we're going to use CLS. And we're gonna push that back into the system and hopefully clear our screen. So it's one of the weird things that Python doesn't have in here is a simple way to wipe the screen. But I thought this one's kind of interesting. And then from time, so we could import the entire time library. In this case, we only imported the sleep function. So we could put something to sleep for a specific amount of time. Now, those aren't exact on those pieces. But the sleep functions are kind of interesting to be able to use. So, and depending on your machine, I haven't had 100% luck with this running inside of the idle environment. It works much better if we actually run this. So if I can find my file here. Documents, Python files. So, it works a lot better typically in this environment than it does in the, what it does is essentially waits 5 seconds there. So, just some things to try that have worked in the past. As we get new and wonderful updates, we'll get different things. But what's interesting is what it returns out of this when you query your own system through this. That NT came out in about 1998. So it was called NT for New Technology on Windows, is what it was looked at. All right, so this week, there are some assignments in here, but they're actually due then on this 27th. So we'll have all next week to work on them also. So don't panic yet, but don't wait till the last minute. We took out the 3-3. That seemed to have some kind of an issue. So we're going to look at these as we go through them. And I've hidden some for a little bit until we get ready to do them. So you'll see as we go through here. We'll look at some of these. All right, any questions? You have to do this and try it. If you just wait till Sunday night and you go, man, I'm going to do these assignments, you're going to be sad because we learn from these making of our mistakes. So when I type something wrong, I learn from that as I go through there. Because I go, oh, well, that didn't work. Let me try another way to manipulate this. What I will say is Python is very, very dependent. So here you see this function. It's very dependent on these indented functions. Because what that function here called screen clear, it says, all right, all of these items here that are indented are part of that function. And that's how it tells where things are. So it says, all right, everything here is in this function we're going to run. Everything here is at this level. So formatting is very important in Python. A lot of things it ignores. Indents that are wrong, it doesn't like at all. And in fact, if I were to put a single extra space, and watch it actually run. So notice I put one extra space, and notice it gives me an error saying, oh my goodness, your indents don't match. So it'll either not work correctly like that, you'll get errors, or it just won't work at all, and then you'll be puzzled trying to figure out what the issue is. All right, let's get out of here. Enjoy the nice, freezy, warm day.